Hello. So, there's been some demand, so I've decided I'm going to do a round of recording discussions of some things that are kind of like the various benchmarks. So what we see here is like a full list of a bunch of benchmarks. It'll be posted to Canvas along with the link to all these videos. Let's just talk through these one at a time, just like before. So the first thing I want to talk about is let's talk about composing a proof of some set theoretic thing. It says that I want things to involve image and pre-image, but there's no law that says that I have to. It could just be anything that has to do with set theory. Let's try to prove that set containment. So, let's see. None of y'all at this point are really struggling with this detail, but remember we should write down what we want to prove. So let's let x, comma, y, comma, z be sets. We want to show x union y intersect z is a subset of, notice we actually know this is equal to, but we only want to prove one of the set containments right now. X union y intersect x union z. So I'll be doing like some back and forth between here's like the thing that would be like the final version and another set of paper that I'll have as like some scratch walk. Let's see, I want to prove this set containment. I guess that means I better consider any x in x union y intersect z. And now, let's go off to some scratch walk land. Let's remember what that means. So, right now I have x is in x union x y intersect z. Let's see, I've got it like a union symbol there. So that means x is in x or x is in y intersect z. That looks like maybe I'm going to have some cases. So I think there will be like two cases to worry about. Either x is in x or x is in y intersect z. In the second case, we'll get x is in y and x is in z. And let's remember what the goal is. Goal. X is in x union y intersect x union z. Oh, cool. So what's the goal really? I need to show that x is in x union y and x is in x union z. And now I can look at what I got and try to get some ideas. Let's see, in one of the cases, I know that x is in x. Oh, cool, wait a minute, but that means that x is in x union y and x is in x union z.
Oh, sorry.
Hello.
Are you prepping in here? I was just going to camp out, but...
Yeah, I was using this one for a little bit. Sorry about that.
No, I'm fine.
Union makes sense bigger. Sorry for the little distraction. Oh, neat. But if it's in both of these, then we're in the big thing. So I think that I'll stop there and we're resolved in that case. In this case, well, let's see. X is in y. Oh, cool. That means x is in x union y, again, because union makes sets bigger. And, well, since x is in z, same thing. X is in x union z, because union makes sets bigger. So, I think we're ready to write the proof. We'll consider any x in there. So, either x is in the set big X or x is in the set y intersect z. If x is in x, then as Alright, so what do I really mean by that? I mean like any set is in a subset of the union between that set and another. We know that X is in X union Y, and X is in X union Z. So X is in X union Y intersect X union Z as desired. That's just to say we're done with that case. On the other hand, if X is in Y intersect Z, then X is in Y and X is in Z. As X is in Y, X is in X union Y. Again, because union makes sets bigger. Similarly, as X is in Z, X is in X union Z. As X is in X union Y, and X is in X union Z, those parentheses aren't really needed. They're not long, they're just not needed. Since X is in both of those sets, X is in the intersection. Thus, either way, to emphasize that regardless of which of the two cases we fell into, X is in X union Y intersect X union Z. So X union Y intersect Z is a subset of X union Y intersect X union Z. And that completes the proof. Neato. So, last time, I'm going to do the same thing. I'm going to talk through each of these claims one at a time. I'll post them hopefully with some sort of meaningful names. So I'll hit stop now and see you in the recording of the next one.